Today, yeah. So today we're gonna start with the Android application development cycle. So how the application works, what the development cycle works in the mobile APK file. So if you see over here, they have given a chain. So we can read about the very first one is your Java source code. Then you can see the Java compiler, the Java bytecode, the Dex compiler, the Delvik bytecode, the Delvik executable.dex file, and the Dex files which are zipped into .apk files. So this is a proper procedure how a mobile application basically works in the real life scenarios. For example, if you see one by one, I have described each and everything. For example, let's read about the first one. So they have given the Java source code. So if you talk about the Java source code, it's all about the programming and the build-up source code of an applications. So if you see the definition which is given over here, programmer writes software programs using programming languages like your Java. The programming language provides a series of instructions. They can be used to create programs, and all instructions are programmer used to build programs as well as source code also. So this Java source code is all about the development part where the actual code is written for the application mode. So if you see the Java compiler, the compiler which is basically used for the runtime memory. A Java compiler is a compiler for programming languages. For Java, the most common form of output from the Java compiler is to class containing the platform neutral Java code. So it is basically used to run the program files to escalate with the hardware and operating system combination part. Compiler, if I say the word compiler, is used for compilation, or you can say execution part to give a statement to run. And over here we can see they have neutralized the Java bytecode. What was Java bytecode basically? It's a language to which the Java source is compiled with the Java virtual machine. Bytecode is a compiled format of Java program. Once a Java program has been converted into the bytecode, it is transferred across the network executed by the Java virtual machine, which is a JVM. Same, we have a compiler called Dex compiler. Dex compiler are basically integral part of the Android application development process. It is during the process the compiler's transformation. It is basically used for transformation from the .class file into .dex file. So a class and a Dex file which contains the actual code when they simply run the time. A Delvik byte, you can see a Delvik bytecode. It's also a program which is commonly written in Java and compiled to bytecode to the virtual machine, Java virtual machine. And Delvik, if I'm saying the word Delvik, is basically your Delvik machine, which is used for optimizing or running part. As we have read this one yesterday. Stored in your Delvik.dex file, Delvik executable files. Dex file is known as Delvik executables, and OBDX is optimized Delvik executable files. Related to term ODEX and DDoX associated. So over here they have given the Delvik execution.dex file, which is known as Android programs are compiled into .dex file, which is your Delvik execution files, and they are turned into a zip file, which is your .apk. Android package. A .dex file can be created by the automatically translating compiled application written in the programming language. So when simply we are coding an actual code for the application, it will be on the DEX format. Then we converted the DEX format into a APK file that it can be easily installed in the application that we can use for managing part. So there are. हाँ जी.
डेल्विक सिखा दीजिए एक बार.
जो डेल्विक था आपका, डेल्विक आपकी वर्चुअल मशीन थी, ठीक है, वर्चुअल मशीन जो आपके फोन में इंस्टॉल होती है.
ओके सर.
और ये जो आपका प्लेटफॉर्म जैसे हमारा VMware हो गया, Oracle Virtual हो गया, these are also from workstations. So Delvik is also a workstation which is running in your mobile devices.
तो फिर डेल्विक बनाया किसने है?
डेल्विक बनाया किसने है?
मतलब Oracle ने VirtualBox बनाया, VMware बनाया उन्होंने. तो
let's see Delvik machine Delvik virtual machine creator. Let's see this one. So you can see where is it? I guess this is a continuous process of Android operating system. It's just like an Android operating system, and over here they have given no one describe over here who's the owner of the Delvik machine.
Okay, sir, no issue.
But we can look for the Delvik machine. I'm also curious about that one. Delvik, we can simply write Delvik creator, like this one. Video AQA Ben Boston, the creator of Delvik. Google I/O 2008 Delvik virtual machines internal. So now we have Delvik is a continual process of virtual machines. It's an Android operating system that is execute application with the Android form. Delvik bytecode format is still used as distribution format, and they are no longer runtime. We can see Delvik, and the owner we can see over here for Dan Bornstein, who is a creator of Delvik. They have given one by one.
Yes, sir, sure.
So over
So
here,
basically, like VirtualBox, VMware in laptops and PCs, it's like a Dalvik machine in phones.
it's not, no. Only for the cell phones are for Delvik. Okay.
That's what I'm saying, sir.
For Windows, it's like your VMware workstation on an Oracle VirtualBox. Each and every one has a different virtualization process.
Okay.
Yeah. So at the least in the last, we can see we have a text file which is which are zipped into the .apk file. An APK file is essential to a zip file. You can get one of the rename it and then extract it having the access code. The binary XML file that provides information that a device needs to be runtime. You can see when you simply, for example, let me show you one thing. Over here on my normal device, for example, yes, mobile. Let's try to extract this one. See. You will see all the text files. You see classes.txt file, which has the actual code. And if I open this one, it will not open. And you can say Android.manifest file, which has all the permissions. And over here, this is not going to run. And some libraries. What are libraries they need for execution part? Meta information. Resources, you can see the color bytes. They have given all the color bytes that can be used for the different processes and the parts. And there are many more things that can be done over there. So you can see one by one all the things of the resources given over here. And the most important part is your text file, which is as the actual code written before the zip file. So there are various things that can be done over here, one by one. But the most important part is to extract the services. So over here, you can see, which is given over there, each and every life cycle has a different kinds of things. And the last thing what we get from text files, we get which is zipped into .apk files. And you can also read the source code if you want from the, where is it? Yeah, you can read the source code from here also. You can run the text compiler to check all the files. You can see over here in the upcoming sessions, you will learn something new. You can simply visit this website for code burst. Okay, I think it has been moved. Okay, I guess I have to change this one. So this was a proper process of the life cycle of the Android application development cycle. You can see over here. For better understanding, if you are a good coder, if you write your own Android applications, you can simply move for that. Otherwise, we can see that after that we have Android application component, and this is the important part. In this scenario, we're going to read about the actual source code. What is the meaning of that source code? You can see over here. So if you look over here in the very first stage, they have given Android core building blocks. Core building blocks, which are basically interconnected to receive an activity and provide services to the end users and broadcast the packets So over here you can see the module Android application component, and we can see application component are essential building blocks to build up on applications layers for an Android application. These components are loosely occupied by the applications manifest and Android.manifest that describe each component of the application as they will interacted. So for example, as I mentioned you before, JDX bin. Okay, so I'm going to run this one. JDX GUI, and the file name was Diva. So as we have mentioned before that there will be Android.manifest file, which is basically used to check the permissions of the application files. You can see these are the applications with the permissions. If you're creating any of the malwares, so we have to check the Android.manifest file, which are the permission they are taking for. Class.dex file, if you run this one, okay, this is not JDX will not able to read this one, but we can see the resources.arc where the resources will take. This is a different thing, but the most important part is the resource file is your Android.manual XML file, which contains the permissions. You can see the permission like write external storage input, read external storage, permission to internet. So Android.xml manifest file contains all the permissions regarding to each and every application file. So they have different kind of scenarios which can be worked. For example, if you see this one, they have given the broadcaster receiver, the activity, the intended, the services, and the content provider. So let's have a look. What are these things actually mean over here? So over here, you can see they have given all the things. For example, they have given there are following 4 main components that can be used for Android applications. For example, they have given activities. Activities like they dedicate the UI user interface handle with the user interaction for the smartphones. Services, they handle the background processing associated with an application. Broadcast receivers, they handle communication between the Android OS applications. And the content provider handle the data and the database management issues over there. So these 4 things are basically important for the applications component, main component you can say. Activities, services, broadcaster, content provider. To clear out the user interface, we use activities. For service, we use the application which is running in the back end. For broadcast receiver, is basically used for communication part, and the content provider is basically used to database management. So they have given one by one all the things. For example, they have given what is the use of activities in the real method and what will be the actual code. You can see an activity represent a single screen with a user interface in short activity. In perform an action. For example, an email application might have one activity that so over here you can simply see that they have given the activities. What are the activity things over there? An email application might have one activity that shows a list of emails, another activity to compose an email, and another activity which is reading the mail. Composing, reading. So each and everything has a different activity. If an application has more than one activity, then one of the should be marked as activity that is presented with the application is launched. For example, you can see an activity is implemented as a subclass. For example, here they have given public classes main activity extend. So the main activity which will be performed over here, just like here, this one. Let's open any of this one. So the most important part is to read the source code of the main activity. So over here they have given the view credentials. You can simply look for the main activity which is given over there. So it's all about the Java classes, you can say. Same as you can look over here, the main activity which contains all the application functionality in the data scenarios, which has each and everything for composing and reading the email, or you can say the list of new emails. If you go down for the services, a service is a component that runs in the background to perform long-running operation. For example, a services might play music in the background while the user is different application, or might fetch data from the network without blocking the user interaction with an activity. You can see a service implemented as shown as subclass. You can see a public class, my service, which is basically run on the background server. For example, you can see broadcast receivers. Broadcast receivers simply respond with broadcast messages from another applications or the system. Basically, this broadcast receiver is used for communication between the two clients. You can see they have given the example that an application can initiate broadcast to let other applications to know that some of the data has been downloaded to the device and it's available to them to use. So this is a broadcast receiver who will interact with the communication and initiate and appreciate actions. So broadcast receiver is basically you can say to alert or simply to inform all the application that some of the files has been downloaded from the resources, so that anyone can use those files. A broadcast receiver is implemented as a subclass, and each message is broadcast has an intent object. And the last and the least, we have content provider. So over here, a content provider, you can say component supplies data from one application to another request. Such requests are handled by the method of content resolver class. The data may be stored in the file system. The data may be somewhere in the else entity. A content provider is implemented as a subclass, as a content provider, and also must be implemented as a standard of API that enables another application to perform transaction. So content provider as an application, as a you can say the functionality which is basically used to transfer the data from one server to different server or a request, which stores a data system file. And you can say over there they're gonna use content resolvers class. Public class, my content provider, extend content provider, and you can see public void on to it. So they have given one by one all the things over here. And for more, you can read these things from here. You can simply visit any of the website. Basic part of Android applications, you can see, you can read about more things over here. What is called activity, what are the services started and bound, what are content provider, what are Android intent and broadcast receivers. You can say Android intent. And intents are divided into intent, implicit and explicit. And these are basically used for generally for element applications. Android widget and notifications, you can see widgets are basically used for communication, information widgets, collection widgets, and control widgets. They have given a proper scenario which can be used over there, and a hybrid widget also for communication part. So there are lots of things can be used. So in this scenario, which is given over here, there has the most important part, as I have mentioned, the four activities: activity, service, broadcaster, and content manager. And if you want to read more about these things, you can simply visit the website called tutorials, some other websites. And the most important, this. each and every components on the server basically used on different parts. The basic components of Android applications are following: activities, intent. You can see 5 different things that is basically used for connectivity part. And you can simply look the setting tabs, what are the things we needed for our upcoming sessions. Over here, you can see we need a Linux-based operating system, free open source, mobile forensics, malware forensics, mobile security, Tantico, or Genymotion. So over here, as I mentioned yesterday, that I already have Genymotion on my server system. So over here, start. So in the background, I can see it's running. Yes. So you guys need your Genymotion to be installed. So we can simply use for penetration testing part, mobile application PT. And over here they have given either you could use Santoku, which is forensic tools, forensic iOS. You can use Santoku. And in Santoku they have given pre-established applications that we can use it for. Or we need Genymotion for our upcoming sessions. And there's one more thing. The Android Debug Bridge. So this is the important part, Android Debug Bridge, and this is basically used to communicate with any of the application on the server side. So for example, you can see Android Debug Bridge is a versatile command line tool that is used to communicate with the device. And Adb command facilitates a variety of device actions such as installing and debugging applications. And it provides an access to the Unix system that can be used to run a variety of commands on the system. But the most important part is to understand these 3 components: a client, a daemon, and a server. So over here you can see a client which sends commands and the client runs over the development machines. You can invoke a client by a command line terminal by using Adb command, and which is basically used to command line to communicate with the device. A daemon, which is your ABD, which runs commands on device. The daemon runs a background process on each devices. You can see a server which manages communication between the client and the daemon. The server runs the background process of development machines. So we need Adb on our local server. So you can install Adb on your Kali Linux. So over here you can do apt get install Adb. Or you can simply check, I already have Adb on my server. Adb. And Adb is basically used to communicate with any of the device on the server side. Only the cell phones are used. So over here you can say -A, listen all the network connections. -D, use your USB device. -E, TCP/IP, serial number. You can say push command, copy files from a directory. Pull command, copy a file directly from device. Sync, a local synchronization port. So we're gonna use all the things. For example, shell to run a remote shell command shell on the server side. Let me show you one thing, how you can communicate with this one. There are some few commands just like your adb connect, adb shell, adb device, adb-s, serial ID number, adb install application, uninstall the application, adb push command, adb pull command, adb logcat is a command line used for dump logs for system messages, including stack traces, devices throws and error, and messages. So over here, I have given all the notes which we need for upcoming sessions. For example, let's see how we can communicate. Connect your device using ADB host to a common Wi-Fi network accessible to the both. Beware that all the access points are suitable. You might need to use access point for firewalls. For example, first of all, I will check my IP address of the device. And over here, the IP address, okay, let's connect this one. Now we can see the IP address is 192.168.106. So we have an IP address on our local network. So ping 192.168.0.106. And we can see the TTL value is 64. So over here, what we're gonna do, if you are connecting with a Wear OS device, turn off the Bluetooth on the phone, spread paired connects. Connect the device to the host machine by USB cable. You can use USB cable or you can simply use debugging mode. Set the target device to listen on the port number 5555. So it's a default port. So what you can do when you are doing simply connecting with any other server, you can see find IP address. They have given the permissions. You can use ADB connect and the device name, IP address. But remember one thing, when you're doing a connectivity with this device, use developer options and check USB debugging mode. It should be enabled over there. If it isn't enabled, so we cannot connect with any of the phones. So what I'm going to do, I'm going to write ADB connect and the IP address. So you can see daemon is not running. It's starting now on the port number 503, and the daemon has started successfully, and it's connected on the port number of the device, which is your 506. So let's start next statement. ANTUP, and over there I can see 106 has been connected, and it's making a connection with my local server with the help of ADB. So what I'm going to do, I'm going to write ADB shell. Why? Because through ADB shell we will get a Unix command shell on the server side. See. Let's do ipconfig. No, ipconfig is not working. Let's do ls-all because it's a Linux architecture. So over here, we are now connected with that specific cell phone or cell device over here with the help of ADB. We can write ADB devices to check all the number of devices which is connected. And over here, I have given all the permissions that we need. ADB devices, ADB enumerator not listed. They have given one by one all the things. For example, installing an application. I have already installed the application over here, which is your Diva. But what I'm going to do, I'm going to remove this one. So uninstall, yes. So I have installed the Diva application from the server side. So what I'm going to do, on my Linux system, I'm going to go to the downloads, CD mobile, and we can see our Diva file is over there, which is your diva.beta.apk file. So to install the application that we already connected, so over here I'm going to use ADB install and the path of the application. You can install ADB to install an application on the emulator. which you have connected. So you can see you must use a -t option in the installation part. So over here, what we're gonna do? Adb install debug, and we can see success. So let's see over there. The application has been installed. So through these commands over here, which is given, you can try lots of other things one by one. You must be use -t. They have given state us port forwarding. You can use the port forwarding to redirect the client. You can use the forward command to set up an arbitrary port forwarding, which forward the request to a specific host on a different port. So over here we have the source and the destination. So, but in this case, we have only one PC, one server to penetrate. So I'm not going to use port forward over here. But remember one thing: if you are using the port forwarding, remember the source and the destination. The source would be your testing PC, and the destination would be the different attacker PCB. You can see copy the files from the device. Use the pull and the push command to copy files and device. Install command, which is copy the application part. To copy a file or directory, subdirectories from the device, you can add pull. To copy a file or a directory and a subdirectories to a device, you can use push command. From and to, you can see they have same words but the different meaning. Replace local and remote with the path to the target files directory on the development machine. And device example uses. You can simply add some files over here. Adb Push foo is a normal file that you can use for, and you can give a specific path. For example, adb foo.txt. We can use push command on the SD card, and we can name this foo.txt. So it was push command. So okay, sorry. So I have to use the push command before that. Push. But the file should be over there. So I'm going to make a file over there. It's called foo.txt. And let's try this one. The file has been pushed. Let's check over here. So it was on the SD card. So we're going to go cd SD card, lsf and all. And I can see my foo.txt file over there. Let's see what was file over here. So it was a simple script which I created. So rm foo and rm test. So the command will run like a normal thing. And over here through ADB, we're gonna do lots of things. In some cases, you might need to terminate the ADB server process, then just restart it to resolve the problem if ADB does not support to the command. To stop the ADB server, use the ADB kill server, and you can restart the server by using the ADB command. See, for reference, you can read about these things. You can reissue the ADB commands from a command line of the development machines or the scripts that you can use. For example, they have given the adb -d, -e, -s and the command. What is -d and -e? Direct an adb command with the attached USB command. Return more information about the device attachment. -e command the only emulator. And -s direct an adb command with the serial number. So they have given one by one all the things over here. So these are some basic concepts that can be read over here. There's a huge length. You issue the shell command. You can use the shell command to issue the device command through ADB or entering to the ADB remote shell. See? And we already done this one. ADB shell. Call activity manager. This will also help. With an Adb shell, you can issue commands with an activity manager tool to perform various system actions, such as start an activity, force an activity to process, broadcast an intent. You can see broadcast an intent, modify the device screen properties, and more. So through the activity manager, we can run any commands over there. You can start and stop any of the activities. You can also issue an activity manager command directly from Adb without entering a remote shell. For example, they have given. So we're gonna check one by one all the things over here in our upcoming session. You can see they have given the command that we can use, and we're gonna use some of the commands. Call a package manager. With an Adb shell, you can issue component with the package manager tool is to perform action and queries to install a device, which is a shell. Installation, you can see. So all these commands will be performed in our upcoming sessions. You can see device policy manager, and this is also used for check the policy statements on the each and every applications over there, and we can perform various things. Adb dpt commands, you can see one by one. Take a screenshot. They have given screen cap. Command is utility for taking a screenshot of the device displayed. Adb shell screen snap, or you can see you can share the files. And they have given a proper shell. Here is example screenshot session. Adb shell. You can see screenshot shells, exit, and you can pull the file over there. And you can use a recorder video also. All you have to do is to write Adb shell screen record for the demonstration. And all the activities will be performed over there. So you can use all this command one by one, and we're gonna use these commands in our upcoming sessions. So read ARTB profile of apps, API level 74, ART, which is Android runtime, collects execution profiles, one by one all the things. So in our upcoming session, the important thing that we're gonna learn is the command line and the Adb shells. And there will be lots of other techniques that we're gonna follow. And the most important part is we're gonna perform the Jenny motions. And we're gonna read about the OWASP top 10 of mobile application also. And that would be our, you can see, Android startup process. Or you have to examine how the Android bootloader works. They have given 6 levels: boot ROM, bootloader, kernel. You can see in the kernel we have initializations, we have Zagato, we have daemon, we have runtime. In the Dalvik VM we have system manager, server, and managers, which provides services. They have given one by one all the things over here. So this is also important that we have to understand how this one works. In our upcoming session, we're gonna clear this one.